Hello friends, welcome back to my YouTube channel Maths by Samit Deshmukh. In the last video, we have seen the basic concepts of matrices which we have studied in class 11, in which we have seen the definition of matrices, then order of a matrix, representation of elements of a matrix, equal matrix, and then we have started types of matrix. So now again we are discussing remaining types of matrices. So if you are new on my channel, subscribe the channel and hit the bell icon so that you will get the notification of newly uploaded videos. So let us discuss with the next type, that is triangular matrix. In case of triangular matrix, again two types are there, upper triangular and lower triangular. First try to understand the definition of what? Upper triangular matrix. So in this case matrix is square. In a square matrix means what? Number of rows and number of columns are equal, and if the element of this square matrix satisfies certain condition, at that time this square matrix is called as what? Upper triangular matrix. Now let us try to understand which condition should be satisfied by the element of this square matrix. In a square matrix, if all the elements below the diagonal elements are 0. So let us consider one example. Let A is one matrix. So let its elements are say 2, 6, 8, 0, 3, 1, 0, 0, 5. Let these are the elements of the square matrix. Here we can observe that these elements are nothing but what? Diagonal element. These elements are what? Diagonal element, and the element below the diagonal elements are what? 0. And what is our condition? Element below the diagonal elements are 0. At that time this square matrix is called as what? Upper triangular. Very simple condition is there. If all the elements below the diagonal elements are 0, then square matrix is called as what? Upper triangular. Let us consider one another example. Let B is one matrix. Let its elements are say 1, 2, 2, 0, 5. So here we can observe that these elements are nothing but diagonal element. And how many elements are there below the diagonal element? Only one element is there. And check that the element below this diagonal element is 0. Yes, we can observe that here the element below this diagonal element is 0. If this condition is satisfying, then matrix is called as what? Upper triangular matrix. So we have already written the definition in verbal form. Now we are writing the definition in symbolic form. So A is a matrix. Let us denote its elements by A, I, J, and I am saying that its order is m by n. So if order is m by n and m is equals to n. M is equals to n means it implies that number of rows and number of columns are equal, means matrix becomes what? Square matrix. And in this square matrix elements we have denoted by Aij. So Aij will be equals to 0 because some elements are 0. But which elements are 0? Only the element below the diagonal elements are 0. So now for all the element below the diagonal element, let us try to find out value of I and j. So now this element lies in second row first column, means I is 2, j is 1. If you will observe here, this element lies in third row and first column, means 3, 1. This element lies in third row and second column, so 3, 2, means I is 3, j is 2, because first number represents what? Row, and second number represent what? Column in which that element appears. Here easily we can observe that value of I are what? Greater than j, means element are 0 when I is what? Greater than j. Wherever this condition is satisfying, at that time if the value of element is 0, means definitely these are the element below the diagonal element, and we can say that matrix becomes what? Upper triangular matrix. Means this is the second definition, or we can say that alternate definition in what? Symbolic form. Now in the same way we are discussing about lower triangular matrix. In this case all the element below the diagonal elements are 0, means here what? All the element above the diagonal elements are 0. All the element in a square matrix, if all the element above the diagonal elements are 0, at that time matrix is called as what? Lower triangular matrix. Here also consider one example. Let A is one matrix. Let its elements are say 2, 0, 0, 1, 5, 0, 0, 8, 6. Here we can observe that these elements are nothing but what? Diagonal element, and check that all the element above the diagonal elements are what? 0. The condition is only on what? The element above the diagonal. There is no condition on remaining element. बाकी के element 0 भी हो सकते हैं या non भी 0 हो सकते हैं, लेकिन diagonal element के ऊपर के सब element अगर 0 है, so then we can say that this matrix is what? Lower triangular matrix. Now write down the same definition in terms of notation. Let A is a matrix, its elements are Aij, its order is m by n, and m is equals to what? N. M is equals to n means matrix is square matrix because rows and columns are equal, and the element satisfies which condition? Aij is equal to 0 means not all the elements are 0, but the element above the diagonal elements are 0, and in this case I is greater than j, so here we can say that I is what? Less than j. So when I is less than j, so if you'll observe here, for all the element above the diagonal element, I is what? Less than j, and wherever I is less than j, at that time if the element is 0, we can say that matrix is lower triangular matrix. In the last video we have discussed about diagonal matrix, we have discussed about scalar matrix, identity matrix. Just consider one scalar matrix. Let A is one matrix whose elements are 2 0 0 0 2 0 0 0 2. Here we can say that non-diagonal elements are 0 means matrix is diagonal. Again, diagonal elements are constant means it becomes what? Scalar matrix. In this scalar matrix, we can observe that all the elements below the diagonal elements are 0 means we can say that this matrix satisfies this condition, so it is called as upper triangular. And here we can observe that all the elements above the diagonal elements are also 0 means we can say that this is lower triangular also, means scalar matrix or diagonal matrix or identity matrix are upper triangular as well as what? Lower triangular. Now see the next important definition, that is singular matrix. Now we are discussing when a matrix is called as what? Singular. If A is a square matrix, such that its determinant is equals to 0, if this condition is satisfying, at that time that square matrix is called as what? Singular. Consider one example. So let us suppose that A is one matrix whose elements are say 4 3 6 2. Now we are finding determinant. Whenever we are finding determinant of matrix, it will be denoted by this notation. Write down A and write down what? 2 vertical segment. Here also, instead of using square bracket, if we are finding determinant, write down all these element and enclose this element in what? 2 vertical segments. This is the notation for what? Determinant. Already you have studied it in class 11. Now whenever we are finding determinant, at that time, first take the product of diagonal element, 4 3s are 12, then take the product of diagonal element, 6 into 2 is what? 12. So 12 minus 12 is 0. So here we can observe that the value of determinant is equal to 0. So we can say that this matrix satisfies the condition in the definition, and that's why such matrices are called as what? Square matrices. So simple definition is there: if determinant is equal to 0, at that time matrix is singular matrix. Matrix is what? Singular matrix. And when it is called as non-singular, if determinant is not equals to 0. So let us consider one example. Let the element of the matrix are say 10 2 5 6. Now we are finding determinant of this matrix. So write down the element in the determinant: 10 2 5 6. So first take the product of diagonal element, that is 60, then of diagonal element is 10, which is equal to 50, and we can observe that here value is not equals to 0, means value of determinant is not equals to 0. At that time matrix is called as non-singular matrix. Alternate word for non-singular matrix is what? Invertible matrix. Now see how to find out transpose of a matrix. Now if A is any matrix, means not necessary that it is square matrix. If A is any matrix, then its transpose is denoted by A dash or by A raised to power T. And its element can be obtained by interchanging the elements of given matrix A. So very simple definition is there. We will try to understand this definition with the help of one example. So let us suppose that A is one matrix, and let the element of this matrix are say 2 3 4 1 2 3. Isn't it? Now transpose of this matrix is denoted by, it implies that its transpose is denoted by A raised to power T or simply by A dash. And to obtain the element of this A transpose, we have to interchange the elements of this given matrix, means interchange rows into columns, or we can say that interchange columns into rows. So let us convert this first row into first column, so 2 3 4. Convert second row into second column, 1 2 3. So the new matrix which you have got by interchanging rows and columns of this matrix is called as transpose of a matrix. Simply you have to interchange the rows and columns. Here we have interchange rows into what? Columns. Or in other word, we can say that first column will get converted into first row, second into second row, third column into third row. Means either we are interchanging rows or interchanging columns. The matrix which we will get will be the same here. So hope the idea about how to find out the transpose is very clear to you. Just by interchanging rows and columns of given matrix, the new matrix which you are getting, it's called as transpose of the given matrix. Now here we can observe that if order of this matrix, what is the order of this matrix? 2 rows are there and 3 columns, means 2 by 3. What is the order of new matrix? 1 2 3. 3 rows are there and 2 columns, means 3 by 2. Means if the order is 2 by 3, and then order in its transpose will becomes what? 3 by 2. Means in short, rows and columns are what? Interchanging according to our definition. So means we can say that if order of this matrix is m by n, then order of its transpose will be equals to what? N by m, because rows and columns are what? Interchanging to find out what? Transpose of a matrix. So now using the definition of transpose, we are trying to understand the definition of symmetric matrix and skew symmetric matrix. Now if A is a square matrix, in this case element of the square matrix we have denoted by what? Aij. Aij are the element of the square matrix, and if this matrix satisfies this condition that A and its transpose are what? Equal matrices. As is stand here, A and A transpose are not equal because their orders are not equal. So if this condition is satisfied by the matrix, at that time that square matrix is called as what? Symmetric matrix. So let us consider one example. Let A is one matrix. Now I am arranging the elements so that this condition will get satisfied. Every square matrix is not a symmetric, but now I am taking the elements so that this condition will get satisfied. Let the element of this matrix are 2 3 5 3 0 7 5 7 8. Okay, now we have considered one matrix. Now we are taking its transpose. So implies that A transpose is equal to, whenever we are finding transpose of a matrix, we are interchanging rows and what? Columns. So convert this first row into first column, that is 2 3 5. Convert second row into second column, 3 0 7. Convert this third row into third column, 5 7 8. Isn't it? Now you will observe the given matrix and the new matrix. Check that the two matrices are equal. So check that all the corresponding elements are what? Exactly same. So here we can say that here A is equals to A transpose. A and A transpose are what? Equal matrices. So to satisfy this condition, whatever may be the diagonal element, आप diagonal element कुछ भी ले सकते हो, लेकिन नॉन डायगोनल इधर 3 है तो इधर भी 3 लिया मैंने, यहाँ पे 5 लिया था तो यहाँ पे भी 5 लिया है, और यहाँ पे 7 लिया तो यहाँ पे भी 7 लिया है. If we are arranging the element in this form, at that time only this condition is satisfying. अगर यहाँ पे 5 और यहाँ पे 8 रहता था तो फिर ये दो एलिमेंट अलग होने की वजह से ये कंडीशन सेटिस्फाई नहीं हो सकती थी. सो टू सेटिस्फाई दिस कंडीशन, सो आवर अरेंजमेंट ऑफ द एलिमेंट विल बी इन दिस फॉर्म. एट दैट टाइम ओनली A and A transpose are what? Equal matrices. Or in other word, we can say that if Aij is nothing but element of this matrix. If the element satisfies this condition, means element of this square matrix satisfies this condition that Aij and Aj are equal. Means if you will observe here 3 lies in which row and which column? 3 lies in first row and second column. Means 3 1 A12 is nothing but what? 3. Means element in first row and second column is 3. तो ये element किसके साथ equal होना चाहिए? Aij should be equals to what? Abi. Means A12 should be equals to A21. So now check the element in second row and first column. Second row and first column, is it equal to 3? Means yes, Aij and Abi are what? Equal. If the element satisfies this condition, at that time also we can say that the square matrix is what? Symmetric matrix. Now let us discuss about skew symmetric matrix. Now in case of skew symmetric matrix, this matrix is what? Square matrix, and element of this matrix we have denoted by Aij. If this matrix satisfies this condition that A is equal to minus A transpose or Aij is equal to what? Minus Aji. If any one of these two condition is satisfying, at that time we can say that matrix is what? Skew symmetric matrix. So let us consider here one example so that easily we are able to understand this definition. So here let A is the matrix whose elements are A, 2, minus 3, minus 2, 0, 5, plus 3, minus 5, 0. Now to check whether this condition is satisfying or not, first find out the value of A transpose. So therefore A transpose is equal to, whenever we are finding transpose, we are converting rows into columns. So convert first row into first column. So here we'll get 0, 2, minus 3. Convert second row into second column, minus 2, 0, 5. Convert third row into third column, 3, minus 5, 0. Once the transpose of a matrix is known to us, then multiply to it by minus. Multiplying to matrix by minus means multiplying to all the element of this matrix by what? Minus. And whenever we are multiplying by minus, sign will get changed. The element which is negative will become positive, and positive element will become what? Negative. So what we'll get here? 0, 2, minus 3, minus 2, 0, plus 5, 3, minus 5, and 0. Just we are changing the sign of all the elements. Since we are multiplying to this matrix by minus, means multiplying to all the element of this matrix by minus. Now if you observe the element of A and minus A transpose, check that every element are same, means corresponding elements are same, means our condition, which condition is satisfying. So here we can say that A and minus A transpose are equal matrices, isn't it? And if this condition is satisfying, matrix is called as what? Skew symmetric matrix. In other word, we can say that element satisfies which condition? Aij is equal to minus Aji. So means if this condition also satisfying, matrix is called as what? Skew symmetric matrix. If you observe the arrangement of the element in skew symmetric matrix, diagonal element should be strictly 0. Diagonal element should be strictly 0. At that time only this condition is satisfying. और नॉन डायगोनल, इधर प्लस 2 है तो इधर क्या लिया हमने? माइनस 2. यहाँ पे माइनस 3 था तो यहाँ पे क्या लिया? प्लस 3, बिकॉज ए आई जे शुड बी इक्वल टू व्हाट? माइनस ए जे आई. अगर यहाँ पे 2 है तो यहाँ पे क्या होना चाहिए? माइनस 2. साइन चेंज होने चाहिए दोनों एलिमेंट, ए आई जे और ए जे आई के साइन चेंज होने चाहिए. 5 है तो इधर क्या होना चाहिए? माइनस 5. बट हियर देर इज नो कंडीशन ऑन डायगोनल एलिमेंट, isn't it? But here the condition is on diagonal element also, that diagonal element should be strictly 0. At that time only we can say that matrix is what? Matrix is skew symmetric matrix. Now let us suppose that one matrix is there and its elements are say A, B, C, X, Y, Z, 2, minus 3, minus 8. And if I am saying that this matrix is skew symmetric matrix, using this condition you have to find out value of A, B, C and X, Y, Z. So if this matrix is skew symmetric, then according to this definition or conditions in the definition, diagonal element should be strictly 0. So means it implies that A is B is equal to C is equal to 0. Means diagonal element should be 0 if the matrix, if it is given to us that matrix is skew symmetric. एंड x इज इक्वल टू, अगर यहाँ पे 2 है तो यहाँ पे क्या होना चाहिए? माइनस 2. y की वैल्यू क्या होंगी? यहाँ पे माइनस 3 है तो यहाँ पे कौन होगा? प्लस 3. इन द सेम वे z विल बी इक्वल्स टू, यहाँ पे अगर माइनस 8 है तो यहाँ पे प्लस 8 होना चाहिए, मीन z की वैल्यू 8 होनी चाहिए, बिकॉज this matrix is skew symmetric, means it satisfies this condition that aij and minus aj is equal to what? Minus abi. aij और AJI का साइन क्या होना चाहिए? चेंज होना चाहिए. Hope the idea or the condition in the definition of skew matrix is very clear to you. In this way we have completed all the types of matrices in our syllabus. Lastly, let us discuss about algebra of a matrices. Algebra, in algebra we have studied about four fundamental operation: addition, subtraction, multiplication, division. So first let us discuss about how to find out addition and subtraction of two matrices, then multiplication of two matrices. Division of two matrices does not exist, or we are not able to find out division of two matrices. So in case of addition and subtraction of two matrices, the very important condition that two matrices should be of same order. So here we have considered two examples of matrix A and matrix B. So one example of matrix A and matrix B. So if you'll observe here, two rows are there and three columns are there, means order of first matrix is 2 by 3, and here also two rows and three columns, means order of second matrix is also what, 2 by 3. And whenever we are taking addition of two matrices of equal order, at that time simply take the addition of corresponding element. So means 2 plus 1, 2 plus 1, then what, 5 plus 4, 5 plus 4, then 3 plus 2. Here what we'll get, 4 plus 1, just simply we are taking addition of corresponding elements, 6 plus 2, and lastly 7 plus 3. So will be equals to, see what result we are getting, 3, 9, 3, 9, here we are getting 5, here we are getting 5, 6 plus 2 is 8, and 7 plus 3 is 10. So very simple method is there to find out addition of two matrices. Whenever we have to take addition, the very important condition that what, order should be same. As you stand here, order of these two matrices are same. If orders are same, then simply take the addition of corresponding element to find out addition of two matrices. Same method we are applying to find out what, subtraction of two matrices. Here while taking subtraction, take the subtraction of corresponding element. So means 2 minus 1 will be equal to 2 minus 1. Here 5 minus 4. Then here what will get, 3 minus 2. Here what will get, 4 minus 1. Then 6 minus 2, and lastly 7 minus 3. Remaining part is just simplification part. Here we will get 1, 1, 1. 1, 1, 1. Here 4 minus 1 is 3, 6 minus 2 is 4, and 7 minus 3 will also be equals to what, 4. In this way we are finding subtraction of two matrices. Now the next operation is multiplication. Try to understand it very carefully. So whenever we are finding multiplication of two matrices, this multiplication exists only if columns in the first matrix should be equal to rows of second matrix. अल्फाबेटिकली हम देखें तो C पहले आता है, मीन्स कॉलम्स पहले आता है और रोज बाद में. जस्ट टू रिमेंबर दैट कॉलम्स ऑफ फर्स्ट मैट्रिक्स शुड बी इक्वल्स टू व्हाट, रोज ऑफ सेकंड मैट्रिक्स. अल्फाबेटिकली मीन्स ABCD में C पहले आता है, R बाद में आता है. तो आप ऐसे ही ध्यान में रख सकते हैं कि पहले मैट्रिक्स का क्या देखना है आपको, कॉलम, और सेकंड मैट्रिक्स में क्या देखने हैं आपको, रोज. और इफ कॉलम्स ऑफ फर्स्ट मैट्रिक्स विल बी इक्वल टू rows of second matrix, if this condition is satisfying, at that time only we can say that multiplication exists, otherwise multiplication does not exist. So here we have taken two matrices A and B. What is the order of first matrix? 3 rows are there and 2 columns, means its order is 3 by 2. And here how many rows are there? 2 rows and 3 columns, means 2 by 3. 2 rows, 3 columns, isn't it? Now we are finding multiplication of these two matrices AB. So try to understand how to take the multiplication. Okay. First let us check whether this multiplication exists or not. चलो पहले मैट्रिक्स के कॉलम्स, कितने कॉलम्स है यहाँ पे, ये रोज है और ये कॉलम्स है. 2 columns are there. And in the second matrix how many rows are there? 2 rows are there. First number represent what? Rows. And here second number represents what? Column. Means column of first matrix will be equal to rows of second matrix. Means multiplication exists. Now to find out multiplication, multiply by row टू द कॉलम. रो से कॉलम को मल्टीप्लाई करना है, यानी जितने एलिमेंट यहाँ पे रोज में होते हैं उतने ही एलिमेंट यहाँ पे कॉलम्स में होते हैं. नाउ व्हेनेवर वी आर फाइंडिंग मल्टीप्लिकेशन, we are multiplying by row to the column, means we are multiplying by first element to this first element plus then take this multiplication, isn't it? So in this way we are finding multiplication, multiply by row to the column. तो पहले एलिमेंट से पहले एलिमेंट को मल्टीप्लाई करना प्लस सेकंड एलिमेंट से सेकंड एलिमेंट को मल्टीप्लाई करना. अगर थर्ड एलिमेंट रहता तो यहाँ पे थर्ड एलिमेंट से को मल्टीप्लाई करते थे हम. But when it is how, when we can say that number of element in row and number of element are in column are equal if this condition is satisfying, and that's why we can say that multiplication exists only if this condition is satisfying. So well, let us see here. 4 and this product is 12. 4 plus 12 will be equals to what? 16. Now multiply by this row to the second column, we will get second element. So means what we'll get here? 12 plus 3 will be equal to 15. Now multiply by this row to third column. So 2 3s are 6 and 3 2s are 6. 6 plus 6 is 12. So hope the idea about how to take the multiplication is clear to you. Now we are multiplying by second row to this column. Whenever we are using second row, here we will get the element of second rows. So multiply by second row to first column. 1 into 2 is 2, 2 4s are 8, means 2 plus 8 will be equals to 10. Now multiply to the second column, here we will get second element. 6 plus 2 will be equals to 8. Now multiply to the third column. This 1 into 3 is 3, 2 2s are 4. 3 plus 4 will be equal to 7. Now we are making the use of element of what? Third column. Whenever we are using third row, we will get the element of third row. Now multiply by third row to first column. So 3 into 2 is 6 and 4 into 4 is 16. 6 plus 16 will be 22. Multiply to the second column. So here 18 and this product is 4. 18 plus 4 will be 22. Now multiply by this row to the last column is third column. 3 into 3 is 9 and 4 into 2 is 8. 9 plus 8 will be equal to 17. In this way we are finding multiplication of two matrices. Now we are finding multiplication of B and A. Now observe the matrix B. B is the first matrix, and in first matrix observe how many columns are there. How many columns are there? 3. And second matrix is what now? A. Observe how many rows are there. Yes, 3 rows are there, means column of first is equal to rows of second, means our condition is satisfying, means we can say that multiplication exists. Now perform this multiplication very carefully. We are multiplying by row to the column, and since this condition is satisfying, so we can observe that here 3 elements are there in these rows and 3 elements are there in this column. तो पहले एलिमेंट से पहले एलिमेंट को मल्टीप्लाई करो, प्लस सेकंड से सेकंड को, प्लस थर्ड से थर्ड को. So now observe here what we'll get. 4, again here 6 1s are 6 and here 3 3s are 9. So what is the addition here? 19. Now multiply by this row to the next column. So what we'll get here? 6 plus 12 18. 18 plus 12 will be equals to 30. Now आगे एक भी कॉलम नहीं है, एक कॉलम खत्म हो गए तो फिर रो सेकेंड रो का यूटिलाइज करो. सो इफ यू आर मल्टीप्लाइंग बाय सेकेंड रो, हियर वी विल गेट द एलिमेंट ऑफ सेकेंड रो. मल्टीप्लाई बाय दिस सेकेंड रो टू फर्स्ट कॉलम. 8 plus 1 9, 9 plus 6, 2 3s are 6. 9 plus 6 will be equals to 15. Now multiply by second row to second column. So here we'll get 12. 12 plus 2 is 14. 14 plus 8 will be equal to 22. In this way we are finding multiplication of two matrices. In case of multiplication of two matrices, here we can observe that the value of AB and value of BA are equal or not equal. Same matrices are there. AB, we have taken first multiplication of AB, then we have taken multiplication of what? BA, and we can observe that the results are different, means AB is not equals to what? BA. AB is not equals to BA means whether commutative property holds or does not hold. So here we can say that in multiplication of two matrices, commutative property does not holds. In this way we have completed all the basic and elementary part from class 11th, which is required to understand the concept of what? Class 12th. So in the next video we are starting the syllabus of class 12. If you like the videos, please share these videos with your friends also.